Hello, in this video I'm going to solve question 4 of problem set 1. Suppose that D is a metric on a set X. Prove that this inequality holds for all X, Y, Z, and W in X. In order to prove that a number is greater than or equal to the absolute value of another number, it is necessary and enough to prove that this number is both greater than this number and opposite of this number simultaneously. Okay, so if I want to show that absolute value of x is less than or equal to a, I need to prove that a is greater than or equal to x. I need to prove that a is greater than or equal to minus x. If I can prove these things simultaneously, if a is a positive number, then that is exactly equivalent to this inequality that you see. So that's my strategy. Okay, and then to do this, hopefully you know that the last property, meaning the triangle inequality that we demand on a metric, will help us. Okay. So let me start with this expression. So dx and z plus d, z, and w plus dy and w. You know that this part, according to the triangle inequality, is greater than or equal to dx and w. So I do not touch this part, but I know that the sum of these two is greater than or equal to this one. So this means that this expression is greater than or equal to d x and w plus dy and w. But you know that because of the symmetry of the metric, I can interchange these two without changing anything. So I can just write that this is equal to dx and w plus dw and y. But again, I can apply the triangle inequality here once more, because you see this is dxw plus dwy, so that is greater than or equal to dxy. So what I have done so far, I have shown that this expression is greater than or equal to this expression. So what can I do now? I can move dzw from this side of this inequality to that side, and then I change the sign. So what I get is that dx and z plus dy and w is greater than or equal to dxy minus dzw. Okay, so this is one thing that I showed. Now I used a similar trick. To prove that this expression is greater than or equal to the opposite of this number. And then hopefully you know that's the same trick I'm going to use. This time I will start with dx and y plus dx and z plus dy and w. Okay, so what can I do? I can write this part and use the symmetry here. So what can I do? I can write it as this one is equal to, I would write it as dzx plus dxy and then plus dyww. So what I have done, I have put this in the second position. Instead of dx and z, I have written dz and x, so that I can use the triangle inequality on this pair. This becomes greater than or equal to dzw plus dzy dyw. And then I can use the triangle inequality once more on this pair, and this is greater than or equal to dzw. Okay? And now what I want to do, I want to take this expression and move it to the other side. so it becomes negative. So I have this pair left on the left hand side, so dx and z plus dy and w is greater than or equal to dzw minus dxy. Okay? Now, let us compare these two results. So you see that on the left hand side in these two inequalities I have the same expression dxz plus dyw. On the right hand side of this inequality I have dxy first and dzw second, but here I have dzw first minus dx and y. So these two numbers, as you see, they are opposite of each other. And then I have a number, the fixed number, which is greater than this number and its opposite. So this means that this number on the left is definitely greater than or equal to the absolute value of this number, because the absolute value is either that number or negative the number. So comparing these two results, we have proven this inequality. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.